Hello, today we're going to introduce into Chapter 4, specifically looking at Section 1. Today we're going to focus on power. What is power? And then how do we kind of apply power? So 3 major objectives or essential questions today. Number 1, define work in terms of force and distance and in terms of energy. Number 2, calculate the work done when moving an object. And number 3, explain the relationship between work and power. So start off with, let's remember what work is. Work is a transfer of energy that results from applying a force over a distance. So apply a force over a distance. Force has to be a push, a pull, or a lift. So in doing so, we calculate work by using force times distance. Sometimes we can only part of our force is used to do work. Sometimes if we do it at an angle, we only apply some of the force. Sometimes when we push objects with movement with it, we get in the same direction. So we do double the amount of work. But work, that is work. Now, work against gravity. If we're trying to push an object up an inclined plane, which we're going to talk about here when we talk simple machines next, okay, our work done is theoretically mass of the object times gravity times the height. That tells us how much work we're going to do because we have to factor in gravity. We also know that as the equation for potential energy. So work is equal to mgh. Okay, we might use that. We might not. If we have to use that, I'll tell you in the problem. In the worksheet today, you do not use this equation. You use force times distance the entire time. So power. Power is the rate at which work is done. So power is how much work we can do and then how fast did we do it. That determines how much power we have. Common unit for power is a watt. A watt is a joule per second. That makes sense. Power is work divided by time. Work is measured in joules. Time is measured in seconds. Joules divided by seconds now cancel, so we get joules per second. It's also given in horsepower. Okay, we won't use horsepower, but if you were to see a worksheet problem, which I don't think there is any, that says that you have an object that has 1 horsepower, that's 746 watts. We clean up things in what we talk about. So when you talk about like a lawnmower and how many horsepowers it has 3 horsepowers. That it gives us a better comparison than if we said 22,045 watts. We just say 3.5 horsepowers. Okay. So to calculate power, we need to know how much work was performed and how much time it took. Just a random little fact here. The maximum of power in a human is around 300 watts. So just a little fun fact for you. Now, what we got here, we got 2 situations. Power is equal to work divided by time. Now down here, okay, it states, and I'll move my cursor, apologize for that Michael and Jim do the same amount of work, but do not have the same power. If we look at the 2 people, okay, they're both lifting a 100 Newton barbell. They're both lifting it 2 meters. So because of that, we know that their work is the same. Work is force, 100, times distance 2. They're both doing 200 joules of work. Now the key here is how I know that Michael's doing it with more power is he lifts this barbell in 1 second. Okay? Where Jim lifts it in 10 seconds. So if I were to calculate power here from Michael, I would take 100 times 2 to give me 200 joules of work and divide it by 1 second, which then tells me that his power is 200 watts. Whereas Jim here now, 100 Newton force times 2, which is 200 joules, we've established that, divided by 10, he lifts this object with a power of 20 newtons, or 20 watts. So Mike and Jim do the same amount of work. Michael does it faster, thus he has more power. So here's an example of a problem that you're going to see in the homework assignment for tomorrow. So John lifts a 10 Newton object 10 meters high in 3 seconds. How much work did he do and what was his power? So key components here, okay, asking for 2 things. How much work? What is his power? Okay, and you're given 3 numeric values. 10 newtons, here's a force. 10 meters, there's a distance. 3 seconds, there's time. So how we're going to do this. First thing you do is you're going to calculate work. Work is force times distance. We know the force is 10 newtons. Distance is 10 meters. 10 times 10 is 100 joules. Okay, now take that amount of work and plug it back into this power equation. Power is work divided by time. Work being 100 joules, time being 3 seconds. Power is work divided by time. 100 divided by 3 is equivalent to 33.33 watts. This is like problems you're going to do tomorrow. So you can reference back to this. If you have questions, please email me. Set up an appointment if you need a one-on-one. So thanks. Hope everything's going well. Hope you have a great day.